Alright, part 2 of 8.5. So we're at theorem 8.14, which means we start talking about an isosceles trapezoid, is which a trapezoid with congruent legs. And exactly one pair of parallel sides. And then we have these guys called base angles, angle A and angle C. And then we have angle B, D rather, and angle C. Angle D and C touches the bottom base, so they're base angles associated with the bottom base. Angle A and angle B touches the top base, and they're the base angles associated with the top base. So when we talk about theorem 8.14, it says if a trapezoid is isosceles, then the pair of base angles are congruent, both pairs. And both pair of base angles are congruent. So angle A will be congruent to angle B, and angle D will be congruent to angle C. Okay. Theorem 8.15 says that if a trapezoid is isosceles, if one pair of base angles are congruent, if one pair of base angles are congruent, then the trapezoid is isosceles. Okay. Then we have theorem 8.16. And 8.16 says that we have diagonals AC and DB, and if we have an isosceles trapezoid, if and only if the diagonals are congruent. So in this case, AB is congruent, AC is congruent to BD. Okay. Alright, then we have the concept of the mid-segment. So mid-segment, just like in triangles, trapezoids has a mid-segment as well. And when we talk about a mid-segment of a trapezoid, the mid-segment, in this case we have mid-segment NN, and it's cutting the legs in half on both sides. So when we have a mid-segment, and then is the mid-segment, and a mid-segment is, in the case of a trapezoid, is a segment that connects the midpoint of the legs. Alright, midpoint of the segment of a trapezoid is a segment that connects the midpoints of the legs, which leads us to the mid-segment theorem. Of a trapezoid. And what the mid-segment theorem of trapezoid says is number one, the mid-segment of a trapezoid is parallel to both of the bases. So Mn is parallel to AB, and Mn is parallel to DC. Number two, the mid-segment is equal to half of the sum of the bases. So Mn is equal to AB plus DC divided by 2. Alright, so I have trapezoid PQRS. PQ is oh, it's EFGH. Dang it, I copied the wrong picture. Alright, the diagonals are congruent, so yes, it's a trapezoid. For number 3. For number 4, if this guy is 7, HE, okay, if this guy is 70 degrees, and this guy is 110 degrees, since I know that these guys are supplementary, 180 minus 110 is 70. And these guys are supplementary, 180 minus 70 is 110. Therefore, these guys are supplementary, their base angles and they're congruent, so yes, it is an isosceles trapezoid, base angles are congruent. Alright, number 5, we have a trapezoid JKLM. We're told these guys are 90-degree angles. We have some mid-segment NP. We're told that JK is 9, NP is 12, with this guy. Okay, so We know from the mid-segment theorem that MNP is equal to 1/2 JK plus ML. So this is 12, and that's 1/2 9 plus M multiplied both sides by 2. 24 is equal to 9 plus ML subtract by 9. ML is equal to 15. And that makes sense because 15 plus 9 is 24, divided by 2 is 12. Or a kite. So a kite is completely different from a quadrilateral, that's a parallelogram, and a quadrilateral, that's a trapezoid, in that there are absolutely no opposite sides that are parallel. Alright, so if something is a kite, we have consecutive sides that are congruent. And consecutive sides are sides that touch each other as opposed to opposite sides. Right? As opposed to opposite sides. So since this side up here touches that side down here, they are consecutive. Right? AB touches BC, they're consecutive, they're congruent. AD touches DC, they're consecutive, they're congruent. And the guys that are opposite of each other, the angles are congruent. So we'll talk about that in a second with the two theorems. So a kite, it's a quadrilateral that has two pairs of consecutive sides that are congruent. Okay, so in contrast to a parallelogram, right, we had, opposite sides that are congruent. This guy and this guy were congruent, and this guy and this guy were congruent, right? And they were opposite sides because they never touched each other. These two guys touch each other, that's the difference which makes them consecutive. All right, that leads us to theorem 812. And theorem 812 says that if a quadrilateral is a kite, then the diagonals are perpendicular. So AB, AC is perpendicular to BD. Right? If a quadrilateral is a kite, then its diagonals are perpendicular. And we got theorem 8. It was 818, I'm sorry. So 819. That was 818, the previous theorem. Not 812. 818. Yay. Okay. Okay, and then 819. We have A and C. So the way I think about it is the part that are not congruent to each other, when they touch each other, they produce the opposite angles that are congruent. So if a quadrilateral is a kite, then it has one pair, exactly one pair. Of opposite angles are congruent. So in this case, angle A is congruent to angle C. However, angle B is not congruent to angle D. Okay. Kite. Alright, so we have a kite here. And notice it's in numerical order. Usually the highest number, well, it really depends. But we're going to go in number order. And we're going to set the two opposite sides equal to each other. So we have so this is going to be 90 here, 90 here. So that's 90. This is 120. And this is 75. Okay. We'll make that 3x. Since opposite sides are congruent, I'm going to set 3x equal to 90 and x is equal to 30. That is this section, I believe. I hope you have a great rest of your day.